In the vast expanse of our night sky, a silent battle is underway. Across the globe, astronomers and stargazers alike are witnessing a growing phenomenon, the encroachment of artificial light, not only from our cities, but now from thousands of satellites orbiting high above the Earth. This is the new frontier in the fight against light pollution, a form of pollution that, though invisible in our daily lives, is quietly transforming our relationship with the cosmos. Light pollution has long been a concern for those who cherish the night sky. The glow of urban centers washes out the faint light of stars, making it increasingly difficult to observe the wonders of our universe. For decades, efforts to combat ground-based light pollution have focused on smarter street lighting, shielding outdoor lamps, and advocating for dark sky preserves. But as technology advances, a new source of interference has emerged, one that cannot be dimmed with local ordinances or clever engineering on the ground. In recent years, the launch of large constellations of communication satellites has fundamentally altered the night sky. Companies like SpaceX, OneWeb, and Amazon are sending thousands of small satellites into low Earth orbit to provide global internet coverage and other services. These satellites, with their reflective surfaces, catch sunlight and create bright streaks across the sky, an unintended but unavoidable side effect. For the naked eye, these satellites can appear as moving points of light, but for sensitive astronomical instruments, they are far more disruptive. Long exposure images become riddled with bright trails, contaminating data and obscuring the faint signals from distant galaxies, stars, and even potentially habitable exoplanets. The problem is more than aesthetic. Astronomy is not simply a pursuit of beauty. It is a science that relies on precise measurements of faint light. With each new satellite, the challenge of separating ancient starlight from the glare of modern technology grows more daunting. Astronomers are sounding the alarm, warning that without intervention, vital research could be compromised and humanity's ability to explore the universe diminished. Yet within this challenge lies an opportunity for innovation, a chance to blend the frontiers of science, engineering, and materials technology. One promising solution is deceptively simple. Make satellites less reflective by coating them with ultra-black paint. At first glance, this might seem like a minor tweak, but in the realm of astronomical observation, every photon counts. Reducing the reflectivity of satellites could significantly diminish their impact on both professional and amateur observations. Ultra-black paint is not your ordinary matte coating. It is the product of cutting-edge material science, designed to absorb nearly all incoming light across a wide range of wavelengths. The most famous of these materials is Vantablack, a nano-structured carbon material that absorbs up to 99.965% of visible light. When applied to a surface, it creates an appearance so dark that the object's three-dimensional features become nearly imperceptible to the human eye. For satellites, such coatings offer a way to drastically reduce the amount of reflected sunlight that reaches observers on Earth. The application of ultra-black coatings to satellites is not without its challenges. Satellites must withstand the harsh environment of space, extreme temperatures, intense radiation, and micrometeoroid impacts. Any coating must be durable, lightweight, and compatible with the other materials used in spacecraft construction. Furthermore, the paint must not interfere with the satellite's operation, particularly its thermal control systems, solar panels, or communication equipment. Early experiments have shown promise. SpaceX, in response to concerns raised by the astronomical community, began testing DarkSat, a version of its Starlink satellite coated with a darkened surface. Initial results indicated a significant reduction in brightness, up to 55% less reflective than earlier models. However, some astronomers noted that the reduction, while meaningful, was not enough to fully solve the problem. The quest for better solutions continues, with researchers exploring advanced nanomaterials, multi-layer coatings, and even deployable sunshades. But technological solutions alone are only part of the answer. The fight against satellite-induced light pollution also requires collaboration, transparency, and ongoing dialogue between industry, scientists, and policymakers. The International Astronomical Union and other organizations are working to establish guidelines and best practices for satellite design, encouraging companies to consider the impact on the night sky from the earliest stages of development. At the same time, the public has an important role to play. The night sky is a shared heritage, a source of wonder and inspiration for people around the world. By raising awareness of the issue, supporting dark sky initiatives, and advocating for responsible satellite deployment, communities can help ensure that future generations will have the opportunity to gaze upon the stars as our ancestors did. As we look ahead, the challenge of preserving dark skies in the age of satellite megaconstellations is emblematic of a broader tension between technological progress and environmental stewardship. Satellites bring undeniable benefits, expanding internet access, improving navigation, and enabling scientific discovery. Yet these advances must be balanced with a commitment to protecting the natural world, both on Earth and beyond. In this spirit, the development and deployment of ultra-black paint for satellites stands as a testament to human ingenuity. It is a tangible example of how science and technology can be harnessed not only to advance our ambitions, but also to safeguard the beauty and integrity of our planet's celestial environment. By embracing such innovations, we affirm our responsibility as stewards of the sky, ensuring that the wonders of the universe remain accessible to all. The fight against light pollution from satellites is far from over. It will require ongoing research, investment, and cooperation across borders and disciplines. But with every step forward, from the laboratory to the launch pad, we move closer to a future where the brilliance of human achievement does not come at the cost of our connection to the cosmos. In the darkness of the night sky, we discover not only the secrets of the universe, but also the enduring light of human curiosity and care.